All right. I'll go as fast as I can to get you out of here. So take out a calculator. Make sure it's in radian mode, all ye physics people, before we start. Yep. The first one's not calculator active, but just while I'm chatting on here, we'll get the calculator going. Physics, hit your mode, go to radian, and we're going to start. This one's a little different than the one in the packet. So the one in the packet, I gave you the velocity, and on this one, I'm giving you the acceleration. So I suggest on all things particle motion, you write this guy over here so it'll trigger what to do. If you want to go that way, you're going to take a derivative either by hand or Math 8 on the calculator. If you need to go that way, you're going to integrate by hand or either Math 9 on the calculator. So you got to figure out which way you're going to go. So on this one, I'm going from the acceleration to the velocity. The one in your packet was the reverse. So I don't like to do things identical. I want you to see everything. So if you go over to this model, if they give me an acceleration and I want to go back to velocity, I will need to integrate, correct? So I'm going to integrate 2t with respect to t. It's an easy integration because I'm not testing do you know how to integrate for this. I'm testing do you understand particle motion and how to work with those levels. There, you can just sit right there, hon. And there's a paper right there. So we'll go integrate this. And it's going to give me a model. Notice that my answer is not going to be a number. I just want to know how do I get the velocity at any time t. This would be t squared, but don't forget what? Yes, plus c. So how do I go get the c? This guy. Yeah, my velocity model, my v of t needs to spit out a -4, right? When t is a 0. So when 0 goes in, a -4 has to come out. So usually the c is what the v of 0, but so that's my model that will give me the velocity at any given time. So if you were asked what's the velocity at time 1, -3. Does that make sense? Do you get why I integrated? Right? Because I was going backwards on this one. The one in your packet, number 20, you were going that way, so you should have taken a derivative. So make sure you can work both ways. When does the object change direction? That's a question about velocity, and I have the velocity model right here. So to figure out where it changes directions, you need to know where it's equal to what? 0, yeah. So go ahead and put your velocity line on here. And go ahead and it'll be easy. I'm not testing can you factor or anything. This is just all about do you understand the movement? So go put a 0 right here for your velocity, right? Then what do? Plug in. Yep, go ahead and just test to the left. It'll be easy to run the quick little test. Test to the left, test to the right. So answer the question, when does the object change directions? When t equals 2. And if I say justify, you'll say because this is when the velocity changes signs. All right, so we were given acceleration, we integrated to go to velocity, and we're using that right now. This is an old question from chapter 2. When is it speeding up or slowing down at t equals 1? Which one is it? What two things do you have to look at? Awesome, both of them. It's an old question, but those are all fair game when we're running on a continuum throughout the whole year's the physics stuff. So you're going to figure out what's v of 1. You're going to figure out what's a of 1. You don't have a calculator, which is why they'll be really easy. A of 1 just is right there, 2. And v of 1 is what? -3, yeah, here's your model for velocity. You might want to box it in because you'll probably be using it quite a bit. Then answer the question with a reasoning. So is it speeding up or slowing down? Slowing down because velocity and acceleration are opposite signs. Don't say they're fighting each other or anything like that. Those are my words. Just say they're opposite signs. Are we good so far? Yes? That was actually nothing new. Well, we had to integrate up there, but we mixed in the old particle motion. So set up and evaluate an integral. That will give you displacement. All right? So when I set up an integral that's going to give me displacement, I have to go from velocity back to, position. So I'm going to be integrating. What will I integrate, though? Be very careful. T squared minus 4. Yep, I'll integrate that velocity. Does it need absolute value bars? Nope, it won't. This says displacement. I could change a word, though, and then I would need absolute value bars. Total distance traveled. Excellent. All right, so this will be the setup of the integral. That'll give you the displacement. When it says to evaluate, it means you actually have to go anti-derivate that guy, right? And then what do I need to do with it? 0 to what? 3, yep. Try to get that off of there. 0 to 3. Top in first, so you have 27 thirds, which is 9. It looks like minus 12. I'm just putting the 3 in real quick. And then minus 0. So it's negative 3. That's its displacement. What does that mean about the particle? It's 3 to the left from where it was when it started. Are we good? All right. Next one up, set up, but don't evaluate. And that's what I'll tell you on your test tomorrow, too. I will have a couple that just says set it up and don't evaluate. I will have some ugly evaluates, but I also sometimes am not testing that. So this one just says set up an integral that'll give you the total distance traveled. It says do not use absolute value. So you're going to start off and say it's the absolute value, right? But it says to set up and not use absolute value. So if you leave this, you can lose some points. You don't have to evaluate it, but I need an expression that doesn't have the absolute value signs. Should be quick if you did the rest of it right. Because where did this split from positive to negative? At 2. So you know you're going to go from 0 to 2. In the 0 to 2 interval, was it negative or positive? So how do you account for that? Negate it. Yep, so you go like this, or you can call it 4 minus t squared, that's fine. Don't forget the dt, plus, where are we going, 2 to 3? What will I put in the other one? T squared minus 4, because it's positive there anyway, so I don't need to negate or use those absolute value bars. And it said don't evaluate, so I'm just going to leave it and I'll get full credit for that. How's that? Now calculator. It says the velocity is given by, so make sure you understand you're on the v level, so let's go put those down so you know. But now we're on our calculator, so nothing will get done by hand. We're just going to set it up and go to our calculator. So velocity to acceleration, that's this way. What button on my calculator? Math 8, but you're going to have to show me that's what you're doing. You can do d dt or d dx, I don't really care, but you're going to take the derivative of that velocity at t equals 2 and then go to your calculator. What's the minimum you round it to? 3 decimal places, not 3 digits. So make sure it's 3 decimal places to the right at a minimum. And this right here isn't a 1, that's a t on the top of that fraction if you're having a hard time seeing yours. So that would go get done on a calculator. And again, make sure you're in radian mode, and maybe I'll steal an answer. Is it what? It's a t over 5. Yep, did you not grab a paper? I'm going to wait. If you're listening to this, I'm waiting for a negative 0.07. Oh, there we are. 0.0706. Something like that. All right, perfect. Did you figure your calculator out? I'll wait for you to work out calculator issues. No big deal. Raise your hand when you're ready to move on. All right, we're ready. The next one, average velocity. It is change in position over change in time, but you don't know position, and you don't know how to integrate with E, so that's not what you're going to do. It's the average of the velocity function. So remember, if you integrate that velocity function, you're going to get change in position from 1 to 4. That word average, what do you need to do with it? 1/3 out front. Exactly, and watch the unit analysis. If this was feet per second and this was second, this will give you a net change in feet, but then when you divide it by 3, you're right back to feet per second. All right, so that one, no absolute value bars, just the average of the velocity function. What do you think? And then you'd use your calculator. I'm going to assume you could do it right. Total distance traveled, all right, would be the integral from 1 to 4 of what? The absolute value of that velocity that I gave you. And it needs nothing out front. We just want to make sure that it integrates everything and makes when we're going backwards positive on the odometer. Right? So when I go back home today, it's not going to count it off of my total distance traveled. So make sure you get those absolute value bars in there. All right. That was the particle motion part. The next part is knowing what you're using. All right, so deadly to apply, and it doesn't matter that you know these names, but when you see this derivative of the integral, what 2 words do I want you to think? dump, only with that derivative there though. If this wasn't there, you wouldn't do it this way. But you're going to put this in for the t, so you'd say 3 times the cubed root of x cosine of the cubed root of x cubed. But then you're not done. Because what was the second word you say? I just dumped it in for the t. Multiply it by what? Derivative of x to the 1/3. So I'm going to write that so you can see what I'm doing if you're going to look at these later. So a couple things. The 3 will stay here. Cubed root x will stay here. Clean this up. And what's the derivative of x to the 1/3 power? 1/3 x to the negative 2/3. So it's going to go like this. All right. It'll be a 1/3 x to the what? So that's actually going to put it on the bottom. 1/3 x to the negative 2/3. So it's going to look like this. Why would I take a point off? First of all, these can cancel. What else can cancel? This, x to the 1/3 over x to the 2/3. What is that? X to the 1/3 on the bottom. So make sure you don't lose little points for cleaning stuff up. But that one, just be careful. The only reason I could do that was because I was dumping it in. This one has 2 ways to do it, and I tell you I really don't care, but make sure if you pick a way, you do it right. So what's one way I could integrate? This isn't a dump and derive. I'm just integrating. You could distribute. So some kids, I'm going to go this route so you can see it. Some people might just say, you know what, these powers are low enough. I'm going to work with 9x to the 3rd and then a 6x squared and a 3x squared. So a 9x squared on the inside, right? 6 plus 3. And then a plus 2x. And they might say, I'm going to work with that. Is that doable? So if Will decides to do that, his route is going to be no changing limits. It's all about x. The limits are for x. He's kept it with x. He's just going to integrate. 9x to the 4th over 4. Right, Will? Plus 9x cubed over 3. 3x cubed. I remember little check on them as you go. Plus 2x squared over 2 from 0 to 1. What will he do? If you go this route, what do you do next? Plug it in. Yeah, 9/4 plus 3 plus 1. Just make sure you can do that accurately without a calculator. All right. Now, maybe Sebastian's seeing that he wants to do u sub. Maybe his u sub is this. So watch. U equals 3x squared plus 2x. So he's sitting there looking at a u, right? What's your du? 6x plus 2. That's a multiple of this, correct? It's twice. So if I did a half du, I would have 3x plus 1. Is his cleaner? Yes, the arithmetic's going to be way easier, but this is where he's going to have to be careful because he's going to do 1/2 and he's just got u du. But what do you have to make sure you do if you're going to work with that? Change the limits. All right? So if it doesn't say to use u sub, you can choose it or not. The answers will turn out the same numerically. Does that make sense, Em? All right. Second to the last one. I'm going to tell you the people who aren't here, which is about, it looks like I've got more than a third of you. A half of them, I'm going to show you what they're going to do on one like this. So I would listen up because it happens every year. So this is something, a benefit of coming to something like this. And they lose all the points because they go like this. They think it's one of those geometric ones, and they know that's an upside down parabola, so usually they'll go like this, and I'll see this on their paper. And they'll draw it. And then it says to go from -1 to 2, and 2 is where it hits. They go like that, and it hits at 0, correct? And they shade this in, and then guess what they do? They use a trapezoid formula. They do. It happens every year. Why can't you? Yeah, this is just the exact area under the curve. You need to integrate from where to where? -1 to 2, 4 minus x. This is not a geometric one because that's not like doesn't make a triangle. It doesn't make a trapezoid or a semicircle. It makes something with curvature that you don't know. This has to be done by hand. All right, so this would be 4x minus x cubed over 3 from -1 to 2. And if you have arithmetic issues, that you have to work out on your own because I want to get you out of here pretty fast. But that would go to arithmetic next, correct? Right? So be careful with that because I always get people who try to use geometry on this one. Don't use geometry unless it says use geometry. All right? So last one, an FRQ. This was from 2015. It's tricky. All right? So I'm saving the more recent ones. There's always a graph analysis. So again, here is my graph of a derivative. I'm thinking right now inches of snow per hour. That's what I've told you to think about. Let's see how you would have done in 2015 on this one. First of all, they're telling you for sure that there's horizontal tangents here, so you know those are for sure turning points, so that you're not guessing. So this is just so you're not guessing at where it turns for sure. Then it says the areas of the regions are 9 and 12. Be careful with going like that. Why do I say that? Because the integral is going to be what? Negative. So if you want to put a 9 and 12 in there, go ahead, but think of them as being under or snow melting or whatever you want to think about, but the definite integral is negative. So part A, it says to find where f has a relative maximum. What's that a question about? Relative max, where f prime changes from what? Positive to negative. That's easy. We should all get that one. At what? X equals -2 for exactly the reason you told me. Because f prime changes from positive to negative. At this point, I call that a freebie. Like with all the ones we've done of that, you should have that down. And then you'd say why, because it says to give a reason. So the next one, it says on what open intervals is f both concave down. So you got to figure out what does f prime need to do before you even go do anything. If f is concave down, f double's got to be negative, right? So what does f prime have to do? Decrease. All right, so I'm looking for decreasing. So f prime, and I'm just going to write that under there. And then I also need f to be decreasing. So I need f prime to be what? Negative. So think about where you're looking and then go write it down. Where am I looking? Below where it's going downhill. All right, this would have been a doable one in 2015. I would have hoped they didn't come back and complain, but I don't remember, to be honest. It's a long time ago. Anyway, hey, can I give you a call back? I'm running a test prep session. No. I have a whole bunch of Calc kids in here right now, but I'm almost done. Okay, bye. Okay, so where was I? Oh, so we'd be on -2 to -1, right? And then union 1 to 3. Or you could put comma 1 to 3. It doesn't matter. All right. And then what are you going to say? This is where f prime is negative and decreasing. Awesome. So next up, none of this is on integration yet because they get mixed. So this is actually old. Doesn't this feel old? It is. But part D, I would have had to cut off in this chapter, in that chapter where we learned all the maxes and mins. But so far, though, not all new. Then it says find x coordinates of inflection. That should be easy for you too. Right? What does f double prime have to do at an inflection point? Change sign. So what does f prime have to do? Increasing to decreasing. So there's 3, or vice versa. There's 3 of them, right? At x equals -1, 1, and 3. Because f prime changes it. Now, the last one. This one is the integration question. So this one's the new one. It's because notice how those flowed well, but it's because we've kind of been keeping this going as we move through. I don't drop a topic. All right, so right here it says f of 1 equals 3. Let's think snowfall. What does that mean if f of 1 is 3? There's 3 inches of snow 1 hour in. Okay, so just kind of think of that. Right here at 1 hour in, there's already 3 inches of snow. I'm going to even just block that off and put 3 inches of snow. Okay, this is a graph of f prime. This would be snow, or inches actually. It says write an expression for f of x. All right, so I want to know the snowfall at any given time. That's first. Expression for f of x that involves an integral. How much is there right now? 3 at time 1. So it's going to be the amount at time 1 plus. We're going to accumulate from what time? From where to where? 1 to whatever's going into the function, right? I'm writing an integral expression that gives you f of x. It'd be 3 plus, if I did it for 1 hour, I'd accumulate for the next hour. What goes under here? F prime. Yeah, and you could put of x dx or of t dt. They call it spelling. So some people's x's even look like t's. They prefer you swap variables, but it doesn't really matter. Right? Now watch me check it. What's the antiderivative of f prime? F of x, right? From x to 1, so it'll be f of x minus f of 1. So I'll be subtracting the 3. Do you see how I get the f of x right back? So for me to do f of 4, I'm going to do 3 plus the integral from 1 to 4. Where do I go to get this? Maybe you have to do it by hand, but this one's a graphical analysis. How do I figure out from 1 to 4? What is it? Be careful with the 12. The integral is actually negative 12. Yeah, so it'll be that 3 that we had already, if you want to think of snowfall, at 1 hour, and then the next 3 hours, it's 12 is going to melt off. That's negative 9. What do you think? And what was the other one, f of what? Negative 2 is going to be the same thing, 3 plus, but I'm going to go backwards 2 hours. You got to be careful, because you're going backwards and it's under. So what are you going to do? You're going to do what with the 9? Add it. Yeah, it would have melted to get you to here, so to go back, you're going to add it on. Perfect. So it would be 3 plus 9, which is 12. What do you think? So we're done. And it was only 15 minutes. Awesome. Thanks. That's good.